Now we're going to look at our trig antiderivatives. So these are the 6 basic ones that correspond to the derivatives that we learned earlier. And so just to refresh our memory, the derivative of sine x is cosine x. So the antiderivative, which means if the derivative here was cosine, then that meant the original function must have been sine. Then of course we have the plus c because there could have been a constant. Since the derivative of cosine x is negative sine x, then the antiderivative of sine x would be negative cosine x plus c. And so on this one, we have to have that negative in there because the derivative of cosine would be negative sine, and so we have the 2 negatives that we need for canceling out. Now, tangent, the derivative of that is secant squared. So the antiderivative of secant squared is tangent x. Since cotangent's derivative is negative cosecant squared x would have an antiderivative of negative cotangent x. And then the last two, the derivative of secant is secant x tangent x. And so the antiderivative of secant x tangent x is just secant x plus c. And then cosecant x is negative cosecant x cotangent x. So the antiderivative of negative cosecant x cotangent x is negative cosecant x plus c. And so when we're doing these antiderivatives, we are looking specifically for these 6 patterns. You can have a coefficient, so you can have a number in front, but our trig has to be one of these 6. If they aren't, then we'll have to do some trig identities using the formulas on that trig identity sheet. So sine x over cosine squared x, that is not something that's in our that's not one of the 6 that we are going to be using. We can't have quotients. There's no quotient rule that we have in this semester. And so what are we going to do? Well, we'll use some trig identities to try to get one of these other functions. So we can use a couple of different things, but the easiest and the most straightforward, the one that's only going to take one step, is if we split that denominator. So I know it's kind of weird when we do this, but we can split that cosine x into a cosine x on the left, a cosine x on the right, and then we can put the sine x with 1. And the reason that's helpful is because that gives us a tangent x and a secant x, and that is one of our 6 rules. It's out of order, but multiplication, the order doesn't matter. And so we know that the antiderivative of secant x tangent x is secant x plus c. And so that's what we have for this antiderivative. Well, in the next one, cotangent x sine x, that is not one of the trig identities. It's not one of the trig antiderivatives that we have, but we can use some of our identities to try to simplify this. This should remind you of all of those trig identities that you did in pre-calc. So cotangent is cosine x over sine x, and then we have our sine x, and the reason this will help is that sine x cancels, and we're left with just the antiderivative of cosine x, which is just sine x plus c. Now this next one, secant squared x, that's on our rule sheet. Sine x is on our rule sheet, and cosecant squared x is on our rule sheet. So we're just going to treat each of these as a separate integral. And so we'll have it like that. The antiderivative of secant squared x is tangent x. The antiderivative of sine x is actually negative cosine x, so we'll make that negative cosine. And then minus cosecant squared x is negative cotangent x. So we can actually make that a plus cotangent x, and then we'll have a plus c for everything. All right, let's do this next one. Here, we have to be careful because there is a negative in front. So this is really like the negative of secant x tangent x plus cosine x. And we can treat these as 2 integrals, so we can bring the negative in front of the secant x tangent x, and then our cosine x. Oh, it left off a dx over there. There we go. And so secant x tangent x is secant, but there was a negative in front. Cosine goes to sine, and we have to add a plus c. So we're just using those formulas, those rules, and it does take some getting used to. It does take some practice. So I've assigned homework out of the book, but I've also added an additional practice sheet that will just give you some additional practice with these antiderivatives because these are the ones that are supposed to come relatively easily. For this particular test, you will have your formula sheet, so you won't have to have these all memorized, but you will have to be comfortable using them. So that's all we have for this intro to antiderivatives. We'll come back to this in a couple of sections, but for right now, we just kind of want to think about this antiderivative as finding the function who has the given derivative.